Right now, somewhere in a field in Ohio or Louisiana or the Nevada desert, a company is pouring more concrete for a single building than most cities pour in a year. That building won't house people. It won't house offices. It will house machines, racks and racks of them, and it will draw more electricity than some entire countries. And here's the part that should genuinely surprise you. The companies building these things say it still isn't enough. They're spending more money, faster, than almost any private industry in history has ever spent on anything, and telling investors they need to spend even more. So why do the richest companies on Earth suddenly need to build power-hungry buildings the size of small towns, one after another, with no end in sight? Stick with me, because the answer touches your electricity bill, your next laptop purchase, and possibly the entire shape of the economy over the next decade. Let's start simple. A data center, at its core, is just a building full of computers that other people rent access to. When you save a photo to the cloud, ask a chatbot a question, or stream a video, none of that is happening on some abstract cloud floating above you. It's happening inside a warehouse somewhere, on physical hardware plugged into a wall. For decades, data centers were fairly modest. Rows of servers, some cooling fans, a backup generator, the kind of building you'd drive past and never think twice about. That's not what we're talking about anymore. And that shift is the entire story. The word hyperscaler gets thrown around a lot, so let's define it properly. A hyperscaler is a company that operates cloud computing and data center infrastructure at a truly massive global scale. Not hundreds of servers, but millions of them, spread across dozens of countries, built to expand almost without limit. Only a handful of companies on Earth qualify. Amazon through AWS, Microsoft through Azure, Google through Google Cloud, Meta, which doesn't sell cloud services to others but builds hyperscale infrastructure purely to run its own platforms and AI models. And Oracle, which has aggressively pushed into this category to host AI workloads for other companies. These five are what people mean when they say the hyperscalers. And right now, they're in the middle of the largest coordinated capital spending spree the technology industry has ever seen. Here's where it gets almost hard to believe. Combined, this handful of companies is on track to spend somewhere between $600 and $700 billion in a single year on infrastructure, the overwhelming majority tied directly to AI and sharply up from an already record year before. Zoom out further, and some Wall Street analysts project this group could spend somewhere near $7 trillion combined over the next 5 to 6 years. $7 trillion. Not one company. That's the collective bet being placed on AI infrastructure by essentially 5 corporations. And it's not slowing down. Executives keep describing their businesses as supply-constrained, not demand-constrained, meaning the problem isn't finding customers who want AI compute. The problem is physically building enough of it fast enough. So the obvious question is, why does AI need this much stuff? Inside a modern AI data center, the star of the show is the GPU, a chip originally designed for rendering video game graphics that turned out to be extraordinarily good at the math behind AI models. Companies buy these by the hundreds of thousands. One recent estimate suggests hyperscalers collectively purchased around 6 million of them in a single year, at roughly $30,000 each, well over $100 billion on the chips alone, before a single building or power line is even factored in. In training, just one large AI model can reportedly consume more electricity than 100 American homes use in an entire year. Multiply that across dozens of models, running continuously, across dozens of facilities, and the scale starts to make sense. But GPUs generate an enormous amount of heat. A conventional server rack used to draw around 5 to 10 kilowatts of power. A modern AI rack can now draw 85 kilowatts or more, and engineers are already designing for 250 kilowatts per rack within a few years. That's an entire order of magnitude increase in less than a decade. Traditionally, data centers cooled themselves with air. Big fans, cold aisles, straightforward physics. That approach is starting to hit a wall, literally. The newest AI hardware runs so hot that air alone can't keep up anymore. This is where the story shifts from big to genuinely strange. To keep up with heat output, the industry is rapidly moving toward liquid cooling, piping coolant directly onto the chips, or in some cases, submerging entire servers in specialized fluid. In just 2 years, the share of AI servers using liquid cooling is expected to jump from around 15% to more than 3/4 of all new deployments. Power is an even bigger constraint than heat. Individual AI campuses are now planned not in megawatts, but in gigawatts, and a single gigawatt is roughly the output of a large nuclear power plant. That's not a metaphor. Some facilities are being sized to consume as much electricity as a reactor produces. Industry forecasts suggest close to 100 gigawatts of new data center capacity could be added worldwide by the end of the decade, roughly doubling the planet's existing capacity. which is exactly why some hyperscalers are now signing deals directly with nuclear power providers, including agreements to restart previously shut down nuclear plants and exploring small modular reactors built specifically to power a single data center campus. A few years ago, a tech company signing its own nuclear power contract would have sounded like science fiction. Today, it's a normal Tuesday earnings call. Here's where this stops being an abstract corporate story and starts showing up in your own life. Take one household in the American Midwest, whose electricity bill jumped from around $100 one month to well over $280 the next, without changing a single habit at home. That's not an isolated story. In one state that now hosts hundreds of data centers, they alone account for close to 40% of all electricity used statewide. And in the regions with the heaviest concentration of data centers, residential electricity prices have climbed by well over 100% in just 5 years. Grid operators in several states have pointed directly to AI data center demand as a major driver of rising household power bills. Some tech companies have started publicly pledging to cover their own electricity costs, rather than pass them on to local ratepayers, a sign of just how politically sensitive this has become. It's not just your power bill either. The race for AI infrastructure has driven up demand for memory chips so sharply that, by one bank's estimate, the price of some memory components has climbed by as much as 400% in just 2 years, costs that eventually show up in laptops, phones, and other everyday electronics. Economists now point to AI infrastructure spending as a real, measurable contributor to broader inflation. Then there's the local impact, the noise, the water usage for cooling, the strain on small-town grids never designed for a facility the size of a small city, and grid connection wait times in some major markets that now stretch past 4 years. It's why you've probably seen local news stories about communities pushing back against new data center projects nearby. It's not only individuals feeling the pressure, the hyperscaler spending spree is reshaping the entire business landscape around them. Smaller AI companies and startups increasingly depend on renting computing power from these same hyperscalers, which means their costs, their growth, and sometimes their very survival are tied to decisions made by 5 giant corporations. When GPU supply is tight, smaller players often end up waiting in line or paying a premium behind the biggest customers. The spending is so enormous that even these hyperscalers, despite huge profits, are no longer funding it entirely out of cash. In one recent year alone, they collectively raised over $100 billion in new debt to help cover the cost, and some analysts project that figure could balloon toward $1.5 trillion in debt issuance over the next several years. Analysts are openly debating what happens if AI revenue doesn't grow fast enough to justify spending at this scale, a question with implications touching bond markets, pension funds, and the broader economy. Meanwhile, industries competing for the same resources, construction crews, electrical equipment, land near power infrastructure, are finding themselves squeezed out or priced up by an industry with essentially unlimited capital to deploy. At this point, you might be thinking, haven't we seen this movie before? In the late 1990s, telecom companies buried enormous amounts of fiber optic cable, betting the internet would need it. Many of those companies went bankrupt when demand didn't arrive fast enough, but the cable stayed in the ground, and years later it quietly became the backbone that made streaming and cloud computing possible. Maybe today's data center boom ends the same way, painful for some companies, but ultimately, infrastructure the world grows into. Or maybe it's different, because unlike buried cable, a data center full of GPUs doesn't sit patiently waiting to be useful. The chips become outdated within a few years, and the electricity bill keeps arriving whether the building is fully used or not. That's exactly why so many analysts are nervous, and why nobody, not even the hyperscalers themselves, can say for certain which version of this story they're living through. So why do hyperscalers keep building, even as costs balloon and backlash grows? Because in their view, building too little is riskier than building too much. If AI demand keeps accelerating and a company lacks the capacity to meet it, competitors will simply take those customers instead. In an industry moving this fast, caution can be more dangerous than being wrong. An arms race where standing still isn't a neutral choice, it's a losing one. Whether that bet pays off is still an open question. But one thing is already certain. The buildings going up in quiet fields right now are reshaping electricity markets, computer prices, and local communities, long before most people ever notice a single one of them. If you found this video interesting, do me a favor and hit like, drop a comment, and subscribe for more videos like this one. I'll see you next time.